but it's a little not politically correct now because it was 1988 and things were different in the movies then. So if you watch it, remember that it came out in 1988. You're not going to watch it, but it's super funny. If any of you have, well, let's see, you're in grade 10, so you might have parents my age. If you had parents around my age that were living in North America in 1988, they've probably, well, there's a chance they've seen this movie and they might think it's hilarious, or they might realize, oh my God, that's the most racist, horrible thing I've ever seen. It's not the most racist, horrible thing you've ever seen, but it's pretty racist. But it's funny. The Three Amigos.
I think I've heard it. It's on the top.
All right. So, is there another x squared?
Yes.
Of course there is. Now, how many of you were taught this move where your teacher says, put a box around all the x squareds, put a circle around all the x's, and put a triangle around all the regular numbers?
Yeah.
Is that okay? Sure it is. I don't care. Right? Here's another thing that I like to do. I like to say, okay, so my x squareds are going together. So 10 plus negative 2x squared. And then I stack them this way. Negative 7 plus 2x. And 6 plus negative 9. And then I just do the math up and down the way you're used to seeing it. Do I care? No. Do it however you want. But here is where I get a little frustrated. I'm going to ask you, what is 10x plus negative 2? And I'm going to hear silence. Oh, I'm so happy I didn't hear silence. Usually I hear silence when I ask kids to do addition. Don't be those kids, okay? Like I have asked kids, what's 7 minus 0? And I hear silence. Grade 11 math classes. Are you going to be those kids? No. So what is 10 plus negative 2? 8x squared. Lovely. What is negative 7 plus 2? Negative 5. Look at you all not being quiet and wussy like my grade 11s. And what is 6 plus negative 9? Negative 3. Oh, stop it. You're going to make me cry. I'm going to have to dry my tears with my tie. Are you greater than Jake now?
No.
No?
I think so.
Is Sophia less than Jake? Okay, nobody got number 3 right.
Wait, no, what?
Well, it's right there.
That's the answer.
That's the answer.
There's no actual answer.
That's the answer. Okay, this is good.
That's not the answer.
Yes, it is an
I
answer.
need a singular answer because when do I know to stop?
When there's no other like terms to collect. Now, Sophia, right now, in grade 10, that's going to be a pretty common answer. In grade 11, and even a tiny bit in grade 10, that's going to equal something. And then you're going to have to do more math.
Yes.
Because when it equals something, you have to get x by itself.
Yes.
And we'll be doing that in a little bit. Dilvir.
Will the question let us know to collect like terms and not to find a single answer?
Well, of course not. It will say something like add or simplify. Because there isn't a single answer. Like, you tell me, what more would you do with that? There's nothing to do, right? There's no other x squareds, there's no other x's, there's no other 3's. There's no more math to do there, is there? Right? And, ladies and gentlemen, that is just as important as knowing how to do math, knowing when to stop. Right? Like if you were running a marathon, which is 42.1 kilometers, you don't need to run for 50. You stop at 42 because it's tiring. Right? I wouldn't run 42 kilometers unless I was being chased by a bear. But that's different. Right? Bears won't last 22 or 42 kilometers, I hope. Well, or I'm running with slower people than me. Anyone? No joke? No. If I'm running with slower people than me, who's the bear going to get?
Slower people.
There you go. That was funny. There we go. All right. Better. Hey, JJ, you're a drummer. I want you to bring a snare and a cymbal so I can get it. Bump. No? No. I want the real thing, man. I'm just joking, JJ. Don't bring a drum to class. All right. Did anybody think they have number 3 right?
I don't even have a dog.
I didn't even.
Seth?
I think.
Okay, Seth. How many cubes have no paint on them?
150.
Yes.
Yes.
How many have one?
150.
25.
Actually, no, I'm sorry. The 0 is wrong, but this is right. It is 150 for one.
Close enough.
How many have two?
Where's 60.
60. I think that's right. And how many have three?
80.
8. Not bad. Not bad at all. Of course, is this a math question? Or is this more of a visualization question? It's more of a visualization. That was a tough word to say with S's and Z's all through it. Man. So, of course, this is 125, by the way. So, how does it work?
No, I didn't even do the question.
There's a cube, yeah?
Yep.
And it's cut into 7 by 7 by 7, yeah? It's a little long in the cube here. Fine. Holy Miss Perfectionist over here. Fine.
Oh my god.
No, no, no. It's got to be perfect for summer.
Oh wow. Summer really?
Close enough, Summer? Anyways, so it's been cut. I got a new computer this year, and for the last 7 years, I've been using the same computer, and I could turn it off so my finger wouldn't move because I'm writing with a pen, but I have a fat hand, and sometimes my hand brushes. And on the old computer, I could turn that off. On the new and improved computer, I can't. So every so often the screen will do what it just did and jump to a different size, and I'll get really frustrated, and you'll laugh because I'm kind of like a Muppet now, and it'll make me angry. Anyways, so this is cut into 7, yeah?
Yeah.
Everyone agree?
Yes.
Okay. And then this is cut into 7, yeah?
Yes.
Everyone agree?
Yes.
And this is cut into 7, and this is cut into 7, right? Okay. So these on the corner, that's the only one that are going to get 3, right? How many corners are there? 1, 2, 3, 4, 5, 6, 7, 8. So the 8 is easy, right? What's going to get 2? Only in the middle here, yeah? So how many are in the middle? If there's 7, the 2 corners have already counted. What's left? 5, right? So there's going to be 5 there. And how many edges are there? 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that one's pretty easy, yeah? What's going to get 1? Just the middle, right? Well, if this is 5 and this is 5, how much is that orange bit? 25, yeah? And how many faces are there on a cube? What's 6 times 25? 150, right? And what's going to get nothing? All the middle, right? Which is 5 by 5 by 5, yeah? So there's 5 across, 5 up, that's 25. And how many layers? 5. What's 25 times 5? 125. Everybody understand? Now, again, the math to do that question was what? Just multiplying, yes? Everybody knows how to multiply. But you had to think about it, yeah? Now, this one is dodgy because back in the day, this was in grade 9, but I don't think it is anymore. Did you do any sort of surface area or volume in the 9th grade at all? You did, Gwen? Where? Were you here?
Like grade 9 and then I completed on it.
Okay, so some people might have done it, and if you're from another country, you've probably done it. but I think it's not in grade 9 anymore. So I'm not going to spend a lot of time with this because I do a unit on this later. But here's what you have to do. Most kids figure this out. If these circles weren't here, right, then you could tell me the area of that, couldn't you? Because you would do 20 times 23, which would be this side, yeah? And you do that times 2 because there's 2 sides, right? And then, of course, you would do this one, which is 20 by 36, and you do that times 2, yeah? And then you do the top, which was 23 by 36. You do that times 2, right? Everybody gets that, yeah? But if I drill holes in it, then isn't this circle going to have to be subtracted from it? Because it's now a hole, yeah? And how many of those circles will there be? 4, because it's drilled right through, yeah? So I would have to subtract 4 circles. Now, some of you probably don't remember that a circle is pi r squared. That's okay. Again, if you don't remember that, is that not remembering how to do it, is that different than not knowing how to do it? Yeah, because right now we're discussing it and all of you are understanding what I'm saying, right? If I drill a hole in it, I got to remove it, right? Now here's the mistake that kids make on this one. When I drill that hole, what did I just make? I made 2 tubes through the box, right? And the walls of those tubes, are they new surface? So should I add or subtract the walls of those tubes? Is it new surface? Here's the box, right? Pretend it's, I need a box.
Box are on your desk.
Where?
Right here.
Where? Ah, this will do, yes. Here's the box, right? If I dip this in paint, everything will be surface, yeah? If I drill holes through it, will paint go on the inside? If I drill holes through this and dip it in paint, will paint be on the inside?
Yeah.
So is that new surface?
Yeah.
So do I add it or subtract it? I add it, but I subtract the 4 circles. Does everybody understand? That is the level of thinking that is required to do Math 10. Notice we did nothing but add, subtract, multiply, and divide, right? The math is those 4 things, but the thinking about it has now changed. Does everybody get what I'm saying? In grade 2, 3, 4, 5, 6, 7, 8, 9, you could get away with, I just do this. In grade 10, I'm going to ask you to think. Oh, says Jake. So it would have been the box, however you got the surface area, minus the 4 circles, plus the walls of the tubes. And if you don't remember the formulas or you never were taught the formulas, no big deal, because what do I care about more? That you understand this or that you can work the formula? That you understand the concept. Because the formula is always the same thing, right? JJ, you just plug in what you have, right? Area equals length times width. Okay, LW, put it in. Everybody cool? All right. Now, should I shut up for a while? Let you guys work a bit? Yeah? Okay, I'll shut up for a while. I'll stop recording. I'll let you. Okay, now, some of you will have cheated on number 5, and you will have gotten out your calculator, and you will have gone 8 and hit the exponent button, whatever the exponent button is, and hit 3, and then divided by 4, and then your exponent button and hit 4, and then hit equals and gotten an answer. Some of you will have done that. That's okay. It's not what I asked you to do. So would I give you full credit? No. What I asked you to do was make them the same base. What's the base there? 8 or 4? 8 is the base. And the base in the denominator is? 4. But I want them to be the same. Are 8 and 4 the same? No. But can they be the same?
Yes.
Yes, because 8 is 2 cubed, right? Because 2 times 2 times 2 is 8. And 4 is 2 squared, yeah? Now I've got the same base, don't I? How many 8s were there in the denominator? Or the numerator? 3. So how many 2 cubes were there? 2 cubed is 8. There's 3 8s. So how many 2 cubes are here? 3. 2 cubed, 2 cubed, 2 cubed, right? And how many 4s were in the denominator? 4, and 4 is 2 squared, right? So how many 2 squareds are in the denominator? 4. 2 squared, 2 squared, 2 squared, 2 squared. Everyone agree? How many 2's are in the top now? No. How many 2's are in the numerator right now? There's 3 right there. How many here? 3 more. How many here?
9.
So there's 2, and there's 9 2's up top in the numerator, yes? How many denominator 2's?
Yeah.
Say it loud and proud. 8. 2 to the 8, right? If there's 9 2's up there and there's 8 2's down there, what do I get to do to these 8 2's? If I wrote it out, I'd have 2, 2, 2, 2, 2, 2, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'd have 2, 2, 3, 4, 5, 6, 7, 8 2's on the bottom, yes? What do I get to do to those 8 2's? Cross them out. What do I get to do 8 2's on the top? Cross them out. Leave me with how many 2's? 1. That's the final answer.
Oh, I just got it different.
You're allowed to get it a different way. Now, that is the very first unit we do. We go over exponents. So if you're a little dodgy, no problem. Number 6. Sophia and I have been having a long discussion about number 6. Number 6 is very important because the kids got the same answer, yes?
Yeah.
Let's pretend I am marking your tests. And I am marking, let's just pick 2 people at random, Sophia and Jake. And I'm marking their tests, and they both write
Can I be
3.
stingy?
Well, don't give me away. They both write 3 to the 14th. But neither one of them shows me any work. Can I give them both full credit? Of course not. Why?
Because we can show them.
Because one of those kids is wrong. Right? Which kid is wrong?
Jake.
Who is student A?
Jake.
Jake is student A?
Yo, Jake's wrong.
Student A is, of course, wrong. So student B is correct. I need you to show me work on tests because the majority of the credit I give you will come from you proving to me that you can do math. All right? Does everybody understand? Yes. If you show me just an answer and the question's out of 4, I'm only giving you 1. Do I make myself clear? You must show me what you did. All right? Even if you used your calculator for the whole time, then I want to know what you punched into your calculator. Everybody with me? Okay. Now, number 7 always causes trouble, and I don't know why. Forward, backwards. What does that mean in numbers? Positive and negative. Because in math, there's how many directions? 2. Positive and negative. In the real world, is there 2 directions? No, there's infinite directions. But once you turn the real world to numbers, they can only go in 2 directions, right? Which way is forward, positive or negative? Excellent. So this would be 5.6 minus 4.3 plus 6.1 plus 2.2 minus 7.2 plus 3.7. And then you would get your answer. I don't even care what it is. The point is that you knew positives and negatives. Because in math, that's the only option you have. Right? If I walk 20 steps north, is that positive or negative?
Forward.
On the number line on Mrs. Bag Crumble's classroom, because you all had it. Right? You all had the number line around the room in elementary school. I'm walking north. Would you make that positive or negative? Positive, because I'm going away from where I started. Everybody understand? Sweet. Okay, now, another puddle of urine because we're doing fractions.
Oh, I just.
How many of you are going to turn all that into improper fractions right now? Be honest, it's not a problem. It's just one way of doing it. How many of you would do that?
Like, do the same thing.
No, first you would make it improper. What is that? All of you have probably been taught the trick that you multiply and add, yes?
Yes.
Okay, so what is the first term there if you turn it to an improper fraction? Because kids always get this wrong. There's a few kids in the class that are going to get this wrong. What's 4 times 2?
6. What? 8.
8. But Sophia's saying, but it's negative 2. No. That's what I mean. It is 4 times 2 plus 3. It is 11 fourths, and that's what's negative. It's not negative 8 plus 3, which is negative 5. Does everybody understand that? And again, think of Mrs. Bad Crumble's number line. There's 0, there's negative 1, there's negative 2, there is negative 2 3/4, yes?
Yes.
So if you're going to turn that into a fraction, and you screw this up, you do 4 times negative 2 plus 3, that's going to be negative 5 over 4, yeah? Which is right there, 1 1/4. Are those the same spot? No. So you have to be careful. Do you know how to do it? Yeah, because you're multiplying and adding. You're doing the circle thing that you were taught. But you're not thinking, are you? Because you're going, 4 times negative 2 is negative 8, negative 8 plus 3 is negative 5. Does everybody understand what I mean? Okay, and then what does this one become? What's 3 times 4? Plus 1. But it's negative 13. So what does that become? Plus 13 over 4. And what does this become? 13 over 3. 3. And then what does this become? 17 over 6. And now what do you have to do? Sophia, say it now.
What?
Say it now.
Oh, get the same denominator.
Common denominator. Let's go. What is it? Say it loud, Tarny. 12. How did I make this 4 12?
Times 3.
So what do I do to 11?
Times 3.
Why?
So that means, yeah.
Because. Jake, I'm going to give you a piece of advice. When I ask a question, if you ever answer because, it's because you don't have the real answer. So if your impulse is to say because, try to rein that in. Because anything you do to the denominator, you have to do to the numerator, or it will no longer be equal, right? So that is negative 33. What did I have to do to 3 to get it to 12? So what do I have to do to 13? Times 4. So that's plus 52. What did I have to do to 6? Times 2. So what do I got to do to 17? How many of you had to get out your calculator to do 17 times 2? Oh, there's some, Dilbear. There's some. What is it? No. 34. And then you do the math. And then you will get your answer. Negative 33 minus 34 is negative 67. Negative 67 plus 52 is negative 15. Negative 15 over 12. How many of you would hand that in to Mrs. Bad Crumble?
No.
Some of you would. Would she give you any credit? She'd be pretty mad, wouldn't she? Huh?
She asked for an improper fraction.
That's true. Mrs. Bad Crumble. Now, I know my kids just went through elementary school. Every teacher they had said, don't ever hand in an improper fraction. I want it as a mixed numeral. Is an improper fraction the exact same as a mixed numeral?
Yes.
Yeah. If I told you that I have 15 twelfths of a pizza, and I told you that you had 1 3/12 of a pizza, do we have the same amount of pizza? Yeah. Is equal good in math? Yeah. So I wouldn't care. But would I care that you left it unsimplified? Yes, I would. That would make me furious. But would I Mrs. Bad crumble you and give you 0? Of course not. Would I deduct a little? Yes, because what's easier to say? 15 twelfths or 1 1/4? If I told you I owe you 15 twelfths of a dollar, or I owe you $1.25, which is simpler? $1.25, right? That's one of my favorite rappers. It's not $1.25, it's $1.65. He's really cool. Anyway, so this is, of course, -1 3/12, which is -1 1/4, or -5/4. Do I care which one you hand in? Never, not once. I can't believe people have done that to you and made you scared of math. Because that, ladies and gentlemen, is what has made you scared of math. Getting work you've done that is correct marked wrong because it doesn't look like what your teacher wanted it to look like. And I do not want you scared of math. There is not one question I'm going to give you this year that you do not know how to do, but many of you are lacking the confidence that you need to do it. And that really, really chaps my hide. Okay? All right. Carry on. Do some more work. You got a break coming up in 6 minutes. Recording there. So everything I said about this is just remember it because I didn't record it. But now remember it because if you watch the video, now it's what I said. Yeah? Okay. That was some good stuff there where we talked about how the math was easy, but the words were difficult. Damn. Sophia, one job. Oh, I didn't actually hire you to remind me to record yet, did I?
No, but you did tell me to remind you that it's check my progress and not check my mark.
Yes. All right. So, I, of course, because I have access to highlighters, I like to highlight my like terms. Why? Because I can. Why not? It's good times. So, 9x minus 5x, 4x squared. 6x plus...
6x plus.
You might have to restart recording.
Jeez. Wonderful, wonderful writing, wonderful writing.
4x squared. And what's 6x plus 5x? 11x. And then, this is where you're going to screw it up. What do I do with that one? 6x and 5x is 11x. Then I got another x over here.
Do you mind?
Negative, negative, right? So how many x's do I have? Well, I actually have about 6, but in math, how many x's do I have? I made a small joke. But how many x's do I have up there? I have 6, and 5 more is 11.
Minus 7.
No, minus 4.
Oh, so you plus.
So it's 15.
So that,
And 9 minus 12.
but wouldn't the first one be 14x?
No. And we'll talk about why in a second. 9 minus 12. What's that? Plus.
Why? This question is so different.
9 minus 12. Danny. 21. Of course. Now, Sophia, you're like, yeah, but shouldn't the first one be 14 then? No, because look, this negative, now, look, I'll use your flying arrows. This right here is actually -1 times 5x squared minus 4x minus 12, which gets you -5x squared plus 4x plus 12. And then you collect your like terms, 9x and -5x, 6x, 5x, and 4x. Yeah? And then 9 and positive 12. And number 11 is a bedmass question, isn't it? GEMS, or whatever this new term is. I have no idea.
I know.
So, where do we start here? Brackets on the left. What math is happening right there? What math is happening right there? Multiplication. So, what do I need to do with that negative 2x? I have to multiply it in, yes? The proper word for that is distribute. Many of you will have heard some other word because for some strange reason, math teachers don't like using the actual word. They like to tell you a story. My grade 10 math teacher talked about how this person out here was trying to break in through the wall of the brackets, like storming the castle. And I was like, isn't it just 2 times 5? Yeah, but he's storming the castle. What? No. I use real words. I call it what it is. Just like when I'm talking to, for example, Gwen, I will not call Gwen Jennifer because that's not her name. Okay? So I'm going to distribute that 2 in here. And I'm going to get negative 8x, positive 12xy, minus 10xz. Yeah?
No.
Yeah. And then what are you going to do next? You're going to make a mistake, I bet. What are you going to do next? Now let's pretend that you still were taught BEDMAS or PEMDAS. I don't like PEMDAS. I'm a BEDMAS man. PEMDAS is parentheses, exponents, division, multiplication, right? Because, well, technically these are parentheses, they're not brackets. But of course, when you get to 1 grade higher than grade 9, grade 10, sometimes we actually use the square ones, which are brackets. So either way, BEDMAS is wrong. So anyway, what are you going to do next? Are you going to do this addition?
No.
Of course not. Why?
Instead of brackets.
Because, yeah, but you can't do anything inside there because there's no like terms.
Division.
You got division. Yeah, buddy. I'm going to move that out of there. Why? Because I can. If my computer is working, but it's not. It's still on highlighter mode. Oh, you're such a piece of garbage. Oh, my Lord. You are such crap. Still crap. Whatever. I'm just going to erase it. Screw you. Fine. Negative 8x plus 12xy minus 10xz. You've got to divide all this by 3x, yeah? So that's the first one. Then I'm going to add this answer. What's 9x squared divided by 3x? 3x. Not x squared. Minus, what's this one? 4xy. What's this one? 18 divided by 3. He waited patiently. 6. xz. Now what do we do with the x's, the xy's, and the xz's? Collect like terms. What's negative 8x's plus 3x's? Negative 5x's. What's 12 plus negative 4xy's? 8xy's. And what's negative 10xz's plus negative 6xz's? Negative 16xz. Yay! Let's go. And the last one. Oh no, algebra. Mr. Myers, why? Why do you make us do it? Because it's math class. You need to do algebra. How many people have finished number 12? Okay, do number 12.
I'm done.
Oh, nothing like winter on the lower mainland.
It's not even yet.
No, it's not even winter yet. We're still a month away from winter.
Oh, yeah.
Again, wait for this.
I can't wait for Christmas either because COVID means wait, I gotta stop recording this in case one of them hears. So, where is the perimeter? Because that's a math word. Yeah, it's the edges around the outside, right? It's this, 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 this. So, what do you got to do to those four things? You got to add them up, yeah? How many x's are there? 2x plus 2.5 plus 4.3. And what does that equal? 13.6. Are those like terms? So we should add them up. 2x plus 6.8 equals 13.6. Now, how do you solve that? It's the easiest algebra I can give you. You got to subtract 6.8, which means 2x equals 6.8, I think.
Yes.
Yep. And then what do you do?
Divided by 2.
Divide by 2. So x equals 3.4. Now, some of this stuff on these 12 questions, I expect you to actually be able to do, right? Some of it I don't. What do you think this one is? I need you all to be able to do that much algebra. If your algebra is dodgy, you're going to have trouble in the 10th grade. We need to fix it. I only see you for 5 weeks, right? And then you disappear. Yeah? So you may need to not seek extra help, because I know you can all do algebra, but you may need to seek some extra practice at it. Everybody cool? We'll see what happens as we go through it, because I will not be doing like a lesson on algebra. Algebra is just part of what we do in grade 10. So we'll be working through, and if you find yourself saying, where did that 7.2 come from? A lot, then you need to work on your algebra. Everybody understand? Cool? Okay. Excuse me. You leave here in half an hour. I like to, where's my next break? I can't remember. I like to give you a little break. I like to end the day at 11:10 because you leave at 11:20. I like to finish my stuff at 11:10. So you can't leave because of the rules, but your last 10 minutes are break. Now, I don't mind moving that back a little, right? And giving you a 10-minute break, like, for example, now. But then we would have to work for the last 20 minutes. That's when I would tie up the day. Maybe that's when we do a quiz, or I do the daily announcements or crap like that, but we would have to work. I don't really care one way or the other, right? Whatever works for you. The first in-class group last quarter liked ending at 11:10. They like work to be done, and then they just kind of chill out for the last 10 minutes.
Yeah.
That's what you all want? Okay. So then in that case, what I'll do right now is I will continue to ask your attention. We'll do the daily announcements, which are not a big deal because I only read the announcements that are applicable to you. I do not read them all. The list of 20 names that have a pickup at the office, I don't do that. It makes me crazy. I've been trying to get them for 13 years to stop doing the announcements over the PA, especially back before you guys got it when we used to have PAC. There'd be like a 30,000 lame list for PAC, and it would take like 8 minutes to do announcements every day. I don't do that. Anyways, I'm going to do that, and then we're actually going to start with some grade 10 work today, but just a little. Okay? Okay. So, we're going to pause the recording. Read. Powers are used to represent repeated multiplication. So what does that actually mean? Do not say a single number. Tell me what that means. Tarni. It means 7 times 7 times 7, which is, of course, 343. Now, at some point this year, in the next day or two, I'm going to say something like, what is 7 to the third power? And somebody in this room is going to say 21. Okay? Or if I say, what is 6 squared? Somebody is going to say 12. No, Gwen, they are. Somebody will. Because they want to say the right answer and they just automatically go, 6 times 2 is 12. It's going to happen. 22 years I've been doing this. Someone's going to do it. The first few times I'm just going to do this. And you're going to go, no, it's 36. The 17th time, I'm not going to be as nice. Everybody understand? All right. So, this construction right here is built of 3 things. The first thing is the base. I'm going to highlight it green. I'm going to highlight it green. I'm going to write the whole note about it in green. Okay? I know sometimes green doesn't look green up there, but it's green here. Trust me. All right? Now, this is problematic because you remember in English class where your teacher asks you to give a definition of something and then you use that word in the definition. And then the teacher's like, you can't use the word you're defining in the definition because nobody knows what the definition is. You know that thing that English teachers do? Well, in this case, you kind of have to do it. So, the base, there's 2 things, 2 important parts of it. There's what it is, and then there's where it lives. Okay? And those are 2 very separate things. All right? The base, what it is it is the value which is multiplied. So 777, right? What if it was y cubed? What would that be? It would be y. Why am I in math class? Right? Because you're going to leave here smarter than you arrived, trust me. Maybe not in math, but in everything else. Everybody cool? That's the base. That's what it is. All right? Everybody understands that. I can put any number, any letter there. You all know what it is, right? Here's the thing that screws you up, and I'm going to change shades of green to do this. There's also where it lives, and this is what messes you up. It lives, and I'm doing this in capital letters for a reason. It lives immediately left of an exponent. Now, here's the problem. I'm using the word exponent here before reminding you what it is, right? And I'm going to talk about what I mean in a second after we have discussed what the exponent is. All right? Now, the exponent is, of course, again, 2 things. There's what it is and there's where it lives. What is the exponent? What information does it give us?
How many times we're multiplying the number on the left?
It's like stereo. Absolutely correct. It's how many multiplications we do, right? So the exponent is the number of times, I didn't leave enough room. The base is multiplied. Everyone understands that, yes? And where it lives, well, if the base lives immediately to the left of the exponent, then the exponent must live immediately right of the base. But we write it up on the up in the corner. It's called a superscript. You're going to deal with that in science. Except in science, how many of you did science 10 yet? Anybody?
I just joined.
Okay, so in science, when you see like a chemical formula, they put the 2's down below. That's called a subscript. Exponents are superscripts. So anyway, it's the superscript, and my pen has stopped writing. Let's see what happens, shall we? Quality technology is key to delivering a blended learning platform in the 21st century. He waited patiently for his brand new machine to do what his old machine does perfectly. He's still waiting. Maybe he should close the program. And then maybe he should open the program. And then maybe he could write again. Yep. The old turn it on, turn it off move. IT 101. It's the superscript. Now, there's a reason I'm making a big deal out of this. Because in grade 9, back when I taught grade 9, you only ever did numbers and numbers for bases and exponents. It was always numbers. You didn't ever use a variable. Is that still the case? No? Good. So all of you are aware you have dealt with that before.
Yes.
Every one of you? Excellent. Okay. Here is the problem. And this applies to, I'm going to highlight immediately left. This is what I'm concerned about. A great many of you do not understand the difference between this and this. What is the base on the left? Now, some of you are going, L, left. Oh, I don't want to say it because I don't know my lefts and rights. I'll make it easier for you. What is the base there where the purple dot is? Just X. So if I were to write this out properly without using the lazy exponent, what would this look like? How would I write that properly? 3 times X times X times X. Oh, it stopped writing again. At least it's almost break time.
Yes.
And what then, while you are waiting for my quality technology to work again, what then is the one on the right, if we were to write it out properly?
3x times 3x.
This one, and I'll change shades of blue, would be 3x times 3x, and it stopped writing again, times 3x. I think the computer is saying it's time to stop for today. So, all right, 3x. Anyway, so the big concern, the lesson I need you to take away from right now is where the base lives. Okay? It's going to get more complicated than that, but that is the thing I was concerned about most. We'll come back to this tomorrow, obviously.